Welcome back, everybody. Shout out, Riggs, if you're watching. Shout out. Let me get this out of the way, too. Okay, so what questions would we like to go over? Why don't you give me a starting point? That's not on. That's
redo number 15.
Yeah, that's algebra 1. Hold on a sec. That's algebra 1.
I want to do one of the graphing ones.
One of the graphing ones?
Yeah.
You can pick which one you want to do.
Probably the
4A, 4B, which you want?
4A.
4A?
4A. Yeah. 4B is just 4B is more straightforward than 4A.
Okay. So you're saying to me you hope that 4B is on the test rather than 4A?
Yes, please. Oh, it's gonna be one of the other we won't.
I don't know. I actually haven't even looked at it yet.
Okay.
I've tried to distance myself from it so I can't lead you in any direction with any sort of hints. I know. I'm trying to be like an ethical teacher.
Yeah, you know.
All right, here we go. Graph the function, give me the following guidelines. Be sure to show all work to support your answer. So, and I will do the same thing that I did on the quiz. I will write up there, these are the things that I want you to do. It's not like I'm going to ask you to memorize those pieces. All right, so let's get started here. First thing, the domain. Really, moreover, is there any restriction on the domain here? Yeah, there is a restriction on the domain. Oh, this is, I'm going to jump back here. 4, 5, 15, 4, 5, homework. Okay, so is there any restriction on the domain? You'd have to look at where the denominator, so I'm going in A here. You'd have to look at where the denominator would equal 0, right? Because I cannot have this happen. Right? Basically, that is my domain. So I subtract over. Well, if I square root -3, what am I going to get? A non-real, right? Radical 3i or I radical 3, whatever it may be. So is there any restriction on my domain? No. My domain is all real numbers. For part B there, I'm going to look at my intercepts, both x and y intercepts. Okay, so for my x intercept, I'm going to look at where the numerator equals 0. X squared equals 0. So x is equal to 0 is my, where it crosses the x-axis. That's the x-intercept, so 0, 0. And then the y-intercept, I'm just going to plug in 0 for x. I'm going to plug in 0 for x. So that's going to be 0 squared over 0 squared plus 3, which in this case, if I get 0 over 3, that's just going to be 0 again. So it goes to the y-axis at 0, 0 as well, which we could have seen that because the x-intercept was 0, 0, but whatever. That's how you do it for any of the problems. You plug in 0 for x and see what you get for y. So I know my x and y intercepts are both 0, 0. Looking at symmetry here. Okay, so let's plug in f of negative x. So in this case, that's going to be negative x squared over negative x squared plus 3. Okay, so that's x squared over x squared plus 3. Sound familiar? That is, so therefore we just stated that f of negative x was f of x. What kind of symmetry is that? Even symmetry, which means it's reflectable over the y-axis. Made that word up. Reflectable. So we have D, the asymptotes. So remember, for any rational function, I would look for the vertical asymptotes of where the denominator can equal 0. Well, in this case, we've already found that. Does that occur? Does that happen? No. So are there any vertical asymptotes? No, not in this case. So vertical asymptotes? None. Now horizontal asymptotes, that's a different story. Do I have the possibility of having a slant asymptote? No, because the degree is 1 greater. It's got to be 1 greater than the degree on the top than the bottom. So that's not happening here, but I do see that I have the same degree on top to bottom. That means I take my leading coefficients. So it's y is equal to 1 over 1. So y is equal to 1. That's my horizontal asymptote. Remember, if it's top heavy, then there is no horizontal asymptote. If it's bottom heavy, then the horizontal asymptote is at 0. If the leading coefficients are equivalent, then the horizontal asymptote is where the leading coefficients are divisible by each other. So y is equal to 1. Questions about that? Excuse me. All right, so now let's take a look at intervals of increase or decrease. Here is where I need to perform the derivative. So if, I'm just going to rewrite this. If f of x is equal to x squared over x squared plus 3, rewriting it so that I can scroll down. Let's find f prime of x. Okay, so that's the quotient rule here, right? F prime g minus g prime f all over g squared. So I know this is going to be x squared plus 3 squared on the bottom. F prime, that's 2x, g, x squared plus 3, minus g prime, okay, that's 2x, f over g squared. F prime g, 2x times x squared plus 3, minus g prime, 2x, f, all over g squared. I think it's Backstreet's Back right there. It's my jam. Okay, what can I do here? Should I just factor? I don't need a fact. I'm sorry, I don't need a FOIL. What am I thinking? Let's just distribute in. That's 2x cubed plus 6x minus 4x cubed, all over x squared plus 3 squared. Combined like terms there. Looks like it's a. Why did I say 4? Sorry, 2 times. It's not a 4, it's a 2. I was going to say those should cancel out. Ooh. Cancel, leaving us a 6x over x squared plus 3 squared. That's my derivative. Now, remember that the maximum or minimum points could occur are where the numerator equals 0 and where the denominator equals 0, because I have to find both the x-intercepts of my derivative as well as where my derivative may not exist. Well, looking at where my derivative does not exist, I'm going to, again, end up with this x squared plus 3 equals 0 again. So do I need to even check where the derivative does not exist? No, because it's going to come up with an I again. So really, all I'm really concerned about is this 6x is equal to 0. So x equals 0, the numerator equaling 0. So my only possibility of a critical point, either a maximum or minimum value, would occur at 0. So let's run our increase-decrease test. Let's see what happens on the left and right side of 0. All right, and I'm plugging this back into the derivative, right? Plugging it back into the derivative. So anything less than 0, well, if it's negative, I'm going to have a negative on top, right? 6 times a negative number is a negative number. And then on the bottom, I'm going to end up squaring it, which is going to end up positive, right? So negative over a positive is a negative. I don't even have to plug in a number. I know that it's going to be a negative over there. Think about any positive number, any greater than 0, that's going to be a positive over a positive, which ends up being positive. Do I have a critical point at 0? Yes, because it goes decrease to increase. And I know that my intervals of increase and decrease, therefore, are negative infinity to 0 is decreasing. Increasing is 0 to infinity. Which means, and I think this is actually f now, extreme values, yeah. So which means that f is, okay, we've got a minimum point, decrease to increase. We've got a minimum point at 0. And we know it's 0, 0, because that's our x and y intercept. So we know that it's constantly decreasing, bottoming out at 0, and then going to be constantly increasing.
So if we were to have to find that y value, do you plug into the original?
Original, yeah. So say this had come out to be 1 instead of 0. We plug that 1 back into the original and find out where it would occur. All right, let's keep it going. Then we've got G, which is our intervals of concavity and inflection points. Now, this is where it gets a little sticky here. I want to take a look at f double prime. So f single prime was 6x over x squared plus 3 square, right? Come on now. That's a plus sign. All right, so f double prime, again, f prime g minus g prime f all over g squared. So f prime is 6, and then we have x squared plus 3 squared. That's f prime g minus g prime. Now, g prime is going to be a little tricky here because I've got to use the chain rule. G prime. So that's going to be 2x squared plus 3, don't change the inner, to the first power, multiplied by 2x, right? Because that's the inner, the derivative of the inner. So that's all g prime, this 2x squared plus 3 times 2x, and then times f. They're rocking out to some classics there. Oh, that's to the fourth power now. Do you see a common factor in here? Look at top and bottom. Do you see the x squared plus 3? Every chunk in here has an x squared plus 3. So what I'm going to do is I'm going to remove that. Oh, black. Remove that. Remove this big here, and then just knock that down by 1. Oh, they're finishing Napoleon Dynamite. That's where that music comes from. I know. Sorry, apparently I can do calculus and listen to a movie. So 6x squared plus 18, and then I've got a negative 2. 2 times 2 times 6, so 24x minus 24x. All over now x squared plus 3 cubed. That looks like my g double prime, or f double prime, whatever that may be, f double prime. You all right, Riley?
Yeah, I just thought the 24 was supposed to be x squared.
No, yo. Now let's combine like terms. I should have checked my key. I would have seen that. Because that should be a negative 18x squared plus 18 all over x squared plus 3 cubed. That's f double prime. Negative 18x squared plus 18. There we go. Apparently I can't listen to it. All right. So that's where the zeros of that are where my intervals of concavity would be, right? Where my possible inflection points. But yet again, I would be checking this x squared plus 3 equals 0. And that's not going to do anything for me. So I'm going to take a look at negative 18 x squared plus 18 equals 0, the numerator. So we subtract over the 18, divide by negative 18, plus or minus 1. Don't forget about the plus or minus whenever you take a square root, because you might miss out on one of the inflection points. Because take a look at what's going to happen when I run my values. Negative 1, positive 1. So when I pick some test values here, if I pick negative 2, and I run negative 2 through that, I'm going to have negative 18 times negative 2 squared plus 18. Oh, I hit enter. Whatever. All divided by, well, look, negative 2 squared is going to be positive, right? Positive plus more positive raised to a third power is going to even more, just going to stay positive. Right? You all done? Okay. You two finish together?
I don't know.
Did you like work together?
Oh, I probably could.
You're in Hudson's, right?
Mm.
Tell him I'll email him. And where are you?
Well.
Right across the hall?
Mm.
Okay. I'll just talk over. So we have negative divided by positive is a negative, right? The whole moral of that story was that's going to be positive. So negative divided by positive is a negative. I'm guessing this is going to be positive in here. But let's check. If I plug in 0, that's going to be 0. That's going to be positive. Positive over a positive is another positive. If I plug in 2, a positive number, negative 18 times 2 squared Negative 18 times 2 squared plus 18. Negative 54 again. We just use this. Negative 54 over a positive is going to be a negative. So that tells me that this is concave down from negative infinity to negative 1, as well as, that's a semicolon, as well as from 1 to infinity. And it's concave up from negative 1 to 1, which means I have inflection points. Okay, I have inflection points at negative 1 or positive 1. And positive 1, I guess. It's not an or, it's an and, whatever. But you know there are 2 places, at negative 1 and positive 1. Just for fun, let's see where that's going to occur. Like, let me plug in 1. 1 squared is 1 over 1 plus 3. So that's actually going to be like 1 comma 1/4. 1 comma 1/4. And the reason why that's going to be important here is because now when I go to graph my function, I know my inflection points are going to be at 1 comma 1/4. I know so the y value is going to go up really small, 1/4. My minimum value is at 0. And look at where my horizontal asymptote is. It's at y equals 1. So I'm actually just going to do this. I'm going to make this 1. Because that's where my horizontal asymptote is. Look, I'll use my dotted line here. There's my horizontal asymptote. I know that it bottoms out at 0, 0. And I know at 1 comma 1/4 and at negative 1 comma 1/4, those happen at the exact same spots. So here is, if this is 1, this is 1/2, this is 0.25. So 1 comma 1/4 is an inflection, and negative 1 comma 1/4 is an inflection. That's where it goes from concave up to concave down. Is that symmetrical? Should be. Not virus. Yes?
So for the 1/4, you plugged in the x value into the original?
To the original, yeah.
Okay.
Yeah, if you're looking to see where it will occur on the graph, you always go back into the original. See, that problem alone took us like a half hour. So that's, I know, we might not get to all of it. Yeah.
That blonde chick that came in here always give you that much attitude.
Yeah. That was nice for her.
Really?
Yeah.
How do you do it on a daily basis?
It's a whole different attitude.
There's a reason why I didn't sign up to be a camp counselor.
She's a freshman though. There's a difference between 6th grade and freshman.
I'd rather have 6th graders.
How about number?
If I took all of their comments personally, I would not be teaching.
How about number 12?
Number 12, sure. Use Newton's method to give the correct value to 8 decimal places. Okay, so the first thing I have to do is kind of figure out what my equation is going to be to use Newton's method, right? All right, so I've got the 8th root of 500 is going to be some value x. Right? The 8th root of 500 is going to be some value, and I'm looking to find x. So that means 500 is really x to the 8th. So if I want to find the 0 of this function, it's going to be 0 is equal to x to the 8th minus 500. That's my f of x. Okay? So therefore, f of x is x to the 8th minus 500. So f prime is 8x to the 7th. Pretty easy derivative there. Okay, so that means we want to figure out what our x1 is going to be. We want to guess at what x1 is going to be. kind of estimate where x1 is going to be so that we can start narrowing it down. Well, what do we think is going to be the value here? Well, think about it. If I'm finding the 8th root of something, like 1 to the 8th power is going to be 1. 2 to the 8th power is going to be 256. 3 to the 8th power is going to be 6,561. So I know that it's going to be closer to 2 than it is to 3, but it's somewhere in between 2 and 3, right? That's how I know that my starting value, it looks like I picked my starting value to be 2. Could you narrow it down even more? Sure, but honestly, you might go past it. Like, what if you accidentally did 2.3 or something like that? You actually went way too far. We'll see in a second. Okay, so that means x2 is going to be 2 minus. Remember that it's always f over f prime. Yeah, I said that right. F of 2 over f prime of 2. Yeah, you're playing Price is Right. You want to guess at it without going over. Okay, so here let's run the values, and I'm going to be particular about how I plug this in. 2 minus, I'm going to put my whole numerator in a parenthesis, x to the 8th. 2 to the 8th minus 500, all divided by, in parentheses, f prime of x. 8 2 to the 7th. I don't know if I need that in parentheses. Well, whatever. There we go. You follow me there? 2 minus 2 to the 8th minus 500 divided by 8 times 2 to the 7th. Yeah, okay, good. I'm good with my parentheses there. So that's x1, right? x2. I am looking to keep running this until I get close enough for how many decimal? 8? 8 decimal places. So what does that mean? That means that I got to keep going. Now, I'm not even 1 decimal place because I was at 2 and now I'm at 2.238 and so on. So now I just go in and I hit second entry, and I just, in place of every 2 that I had, I'm going to put an answer because I want to use that value, non-rounded value, and there. Yep, right there.
How do you put the answer in there?
Second negative sign. Yeah, that's answer.
I did that the other day and I couldn't figure it out.
Okay. If that's a trouble on the test, just let me. I can show you that. I'm not gonna. That's not an issue. I just got to make sure. Okay. Answer. See, I'm technically doing this. Like x3 is going to be my answer minus f of my answer over f prime of my answer. That's what I'm looking to put in my calculator. My answer minus f of my answer over f prime of my answer. Okay, I'm still not even a tenth the same, but now I don't need to re-plug it back in because it's just going to automatically use 2.18, that thing. Go back in, do it again. Boop. Okay, I've got my tenths place correct, right? I'm just narrowing it down more. Okay, now I've got 1, 2, 3 digits correct. Okay, now I've got 1, 2, 3, 4, 5, 6, 7 correct. Almost. Well, that could I round. I could round and say that's 8. But I don't need to. I can just do that. Okay. So do we notice how we have... let me highlight it here. 1, 2, 3, 4, 5, 6, 7, 8 decimal places there. 1, 2, 3, 4, 5, 6, 7, 8, down to the 7. And down to the 7, all correct. I actually have 9 decimal places correct there. That is accurate all the way to that point. I know my actual value must be all the way down there. Okay. Questions about that? Yeah.
How did you get 2? How did you guess 2?
That's where I went and saw, okay, if I'm looking at the 8th root of 500, and I kind of estimate where that's going to be. Think about your eighth roots of numbers. Like if I want to find like the eighth root of 1, that's like 1 to the 8th power is going to be 1 inside there. And then I take 2 to the 8th power. That would be 2 would come out to be 256 inside there. 3 would be way too much. That's way bigger than that number. So I know it's got to be between 2 and 3.
Got it.
Does that make sense?
Yeah. So will it be a question like that where we'd have to like do the root thing, or could it be different? Like,
No, it's going to be similar to this.
Oh, okay.
Yeah, I'm just going to pick a different number and a different root.
Oh, okay.
Questions about that? Okay, what other questions do we got? What do we want to go over? Notice how I did this in all caps here? This parallel to one side. So nobody do this thing where they did on the quiz. Yeah. Can you do 9? That thing? Oh, it's a different one, yeah. But yeah, similar problem. The key is posted online. The whole key is posted. So if I don't get to go over some of those, you can always take a look there and see me some other time. Okay, we got 1,200 square centimeters of material with square base and an open top. Find the largest possible volume of the box. Number 15 on section 4.7 homework. Okay, the key thing here, square base. That's going to be the key to this. Because when I draw this, I know that these two pieces must be the same. Do I know that this is necessarily a cube? No, because this is not the same. The height of this is not the same. But I do see that this is a square base. All right. We've got, I want to maximize volume. Max volume. You ever think I'm talking to you when I say things? Because I say max a lot of things.
Well, sometimes. So
like if you're dozing off.
When we first did this unit, yeah. But
if you're dozing off, does that wake you up?
A little bit.
Yeah, a little bit. Because he does doze off from time to time.
It used to.
Now you just fall asleep no matter what.
I'm just about my sleep schedule. Nobody wanted.
So volume is really equal to x squared y, right? X times y. Now, what's my limiting piece here? I've got 1,200 square centimeters of material. So actually, this is kind of like the reverse of the problem that we had on the quiz where you wanted to like minimize surface area or whatever it was. This, I'm given what my surface area needs to be, and I want to maximize volume based on that surface area. But I don't want to just use all of the surfaces because this has an open top. So that means my surface area is equal to, okay, think about the bottom is x squared. All 4 sides around the outside, are they all going to be the same? Yes, in this case. Because the front and back are both going to be xy. The left and right are both going to be xy. So this is actually plus 4xy. That's my surface area. Okay, so that's going to be equal to 1,200. I know what that is. So let's move everything over to the other side. 1,200 minus x squared is equal to 4xy. And when I say move everything over, I'm trying to solve for y here. Divide by 4x. So 1,200 minus x squared divided by 4x. And you know what I'm actually going to do? Because I'm seeing it on my key here. This is actually easier if I divide it up. Like if I say 1,200 over 4x minus x squared over 4x. So this doesn't become sort of like a quotient rule thing. Because that's going to be 1,200 divided by 4 is 300 x to the negative first. You follow me? Because if it's over x, it's x to the negative first. And this is going to be minus 1/4 x. That's equal to y. That's actually going to assist us when we go to find our derivative in a second. Hopefully I can still see it on the same screen. Close. Okay, so now I take that y and I plug it into the volume equation all the way at the top. So volume is equal to x squared times 300 x to the negative first minus 1/4 x. Okay. Distribute in. This is going to be equal to 300 x, right? Because I've got squared times x to the negative first, which is x to the first. Add exponents. Minus 1/4 x to the third. So that's my simplified. See, that was a lot easier than using a fraction. Now we find our derivative. We want to actually optimize volume. So we find the derivative of volume, which is 300 minus, okay, so 3 times 1/4 is just 3/4. You could say 0.75 if you really wanted to. X squared. And now we find the zero. To actually optimize it, to see when it's going to happen, we're going to set that equal to 0. So let's take negative 3/4 x squared is equal to negative 300. We divide by negative 3/4. So negative 300 divided by negative 3/4. I could have multiplied by 4/3, but you get the idea. 400 x squared equals 400. So 20. I don't need to say plus or minus here because this has context. There's no way I would use a negative 20, so I'm only using positive 20. So 20 is our maximum volume. What does it ask for now, though? It finds find the largest volume. So x isn't my volume, right? Let's go back in and plug it in. You know, I could find my y value associated with this and then find the full volume. But look, I have an equation right here that's going to tell me volume. 300 times 20 minus 1/4 times 20 cubed. 4,000. So volume is equal to 4,000 cubic centimeters. Could I have found y and then found my volume? Sure. Just go back into this to find y, or this to find y, or any of these to find y, and then plug them both back into your volume function to find the full volume. But that's doing it without needing to find y. Yes, sir? 11. So this is very similar to number 12 that we had, right? Use Newton's method with the specified initial approximation to find x3. The only difference between what we're doing now and what we've done with that square root problem is I tell you what x1 is going to be. Because remember, you're going to say, okay, now x1 is 3, x2 must be 3 minus f of 3 over f prime of 3, right? We just got to figure out what f and f prime are. Well, f is 3x to the 4th minus 8x cubed plus 2. So therefore, f prime is going to be 12x cubed minus 24x squared. Okay, so now I go into my calculator and I run that. 3 minus, in parentheses, I've got to do f of 3. 3 times 3 to the 4th. I'm putting things in parentheses that I may not actually need because I'm going to use my second answer thing here in a second. 3 times 3 to the 4th minus 8 times 3 cubed plus 2 cap my parenthesis for the numerator, divided by f prime of 3. 12 times 3 to the third, excuse me, minus 24 times 3 to the second. And then I cap my parenthesis at the bottom. Right? So this is a chunk, the whole thing, chunk, whole thing. Okay, good. That's x2. Right? That's x2. That 2.731481 and so on. 6 decimal places. Now, for x3, basically, I'm going to plug this in my calculator. My answer minus f of my answer, all divided by f prime of my answer. Okay, let's go back in. I need to do my answer here. Now be careful. There was a 3 in my initial equation. I'm not replacing that 3. I'm only replacing where I had my x's. So it was 3 times 3 to the 4th. That's what I replaced for my answer. Come on. There it is. Minus 8 times 3 cubed. And that 3, that's what I replaced with my answer. Plus 2. Then over 12 times 3 to the third. So that's answer to the third. Minus 24 times answer to the second. And that's x3. So correct to 6 decimal places, 2.640435. 640435. That's what I have in my key as well. Does that make sense? So it's really just calculator work, honestly. Figuring out what f and f prime are, and then solving. Good? What other questions do we have?
Can we go through number 2 just so it's like on the video?
Sure.
I know like yesterday we didn't.
Yeah. Just know this. I am on Canvas. There is still my old video going over questions from last year. I'm going to leave that up there too because I don't know if we went over the same questions or went over different questions. So I'm going to leave all of that up there as well, just in case you have one that's answered on there and not on what we did today. You wanted 2, you said?
Yeah.
Yeah. So I'm on record with it.
Mm-hmm.
All right, send to a new page, and let's get this whited out here. All right. Okay. The graph of the derivative is shown. What are the intervals of increase and decrease? So let's go piece by piece. Let's think about the intervals of increase and decrease. Now remember, if this is the graph of f prime, then I know the zeros are where it's increasing and decreasing, where the original function is changing from increasing to decreasing, right? So anything above the x-axis on my derivative is increasing on the original. So that means anything in blue right there is increasing of the original. So from negative infinity all the way to 0.205, and then from 0.673 to infinity. That's all increasing. So what is decreasing then? Well, it's all of that. Anything below the x-axis of the derivative is decreasing of the original. So from 0.205 to 0.673. Okay, those are intervals of increase and decrease, which means that I can now talk about maximum and minimum values. There's one of each. So my maximum value is at, now which one? Okay, so this is going from increase to decrease. From increase to decrease. Maximum value here at 0.205. So therefore, this is a minimum value because it's going from decrease to increase. Minimum value at 0.673. So that's intervals of increase and decrease and extreme values. And then I want to find intervals of concavity. Now, I'm going to forget about all of that stuff that I drew on there. And now think about, where is this increasing or decreasing? Where is the derivative increasing and decreasing? Because where the derivative is increasing, that's concave up. Where the derivative is decreasing, that's concave down. So where is the derivative decreasing? To there, right? That red part is concave down. So concave down is from negative infinity until 0.465. Concave up is all this. From 0.465 to, to positive infinity. Which means that we have an inflection point at that 0.465. And I think I did it all, right? Increase, decrease, extremes, concavity, inflection. Yep. Okay, 5 minutes left. Any other questions?
About 6.
What about 6? What do we have? Oh, I can do this one quick. Come on. Come on. Come on. Oh, new page. The sum of two positive numbers is 16. So what does that say? X plus y equals 16. What is the smallest possible value of the sum of their squares? So I want to minimize x squared plus y squared, right? The S, we'll call it. We're going to minimize that. Well, if I know x plus y is equal to 16, let's solve for x. X is equal to 16 minus y. You know what? I'm going to do the exact same thing I do on my key. I've made that mistake. Okay, I did y equals. I'm going to do, okay, I'm going back. I've learned my lesson. Y equals 16 minus x. So S, I don't think it would make a mistake, make any difference, but you know, I didn't think so before either. We had y is equal to 16 minus x. So I plugged that 16 minus x in for y. So S is now going to be equal to x squared, and let's FOIL this out. 16 squared is 256? Oh, I shouldn't just trust myself. Is that right?
Yeah.
Okay. I just wrote 16. 256 minus 32x plus x squared. Because we have 16 and negative 16 as our inners and outers. All right, so that means S is equal to 2x squared minus 32x plus 256. And now we find the derivative of that. So my derivative, S prime, if you will, is 4x minus 32. Which is a nice and easy equation to find the zero of. Add the 32. So 4x is 32. So that means x is 8. And if x is 8, y is 8. Because x plus y is equal to 16, right? So x equals 8, y equals 8. Because y is just 16 minus 8.
Yeah, I forgot to get the derivative.
Oh, don't do that.
That's a big part.
Don't do that. That's a big part of this.
Yeah,
That's a big part of it. That's like doing a factoring problem and saying, "Oh, I forgot to factor out GCF."
Oh, yeah. That's why I was confused.
Oh, jeez. All right. I'll stop the video here. Again, I'll leave the other video still posted from last year. I'll just make note of it that it was from last year. So if you want, I mean, a